The final type of transformation is a rotation. And we all have experience with rotation. You rotate a globe around. Every time you open a door, it rotates around the axis of the door, which is called the hinges. So we all know what rotations mean in real life. Here's an example of what rotation looks like in geometry. Whoops. Here's an example of what rotation looks like in geometry. There's a shape and it rotated 90 degrees. Here's a shape going 180 degrees around. And here's a shape going 270 degrees around and stops there. So if we take this shape and we rotate it 90 degrees clockwise around the origin, what does that look like? Well, first of all, we have to know clockwise. What does clockwise mean? There's one way of spinning, and there's another way of spinning. What we have to look at is which way does a clock go? And a clock spins that way. You can see the hands spin around that way. So that's considered clockwise. And this says we need to go 90 degrees clockwise. Well, 90 degrees is a quarter turn. So if we keep going another 90 degrees, that would be 180 degrees is a half turn. And 270 degrees is 3 of those, so it would be 3/4 of a turn. And 360 is taking it all the way back to the original, one whole turn around. So the question is, what would this look like 90-degree turn? So if I turned it 90 degrees around, and so the answer would be this one. They look the same. If I were to turn it 2 turns around, that's 180 degrees. If I were to turn it 1, 2, 3 turns around, that would be 270 degrees, and it look like that. And finally, if I were to turn it 360 degrees, it looks exactly like the original. It hasn't changed at all. It's just gone all the way around. How do we rotate a shape? Well, this one to me is a little more difficult visualization, but if you follow these steps, it's pretty easy. So, because when we rotate a shape, we can actually, you don't have to visualize it, we can actually do it on the paper and see what that looks like. So what does that mean in practical terms? So we rotate the entire piece of paper, note the coordinates of the new location, and then turn the paper back around and use that original orientation. So what does that really mean? So let's do an example. So we rotate the piece of paper around. So if let's start again. I have this one and I want to rotate it 90 degrees clockwise and figure out what the orientation would be. So the first thing I'm going to do is rotate the actual paper around 90 degrees. Notice now my y-axis is now my x, and my x-axis is my y. But I'm going to ignore that. I'm just going to now note the location of the new points. So G is at -3, 1. S is at -3, -3. And X is at -1, -4. So I'm just going to write those down. Now that I have what those new points would be, I'm going to turn the paper back around to where it was. And now, finally, I'm just going to draw in those new points. So G goes here, S goes here, and X goes there, and there's my new triangle. So if I take that original triangle and I rotate it around 90 degrees to the clockwise, it will look the same as that new triangle. And I could tell that because when I just rotate my paper around, I could see that those triangles were the same.